A solution of an equation is basically some value that if you take it and you plug it in for the variable terms in the equation, it will make the equation be true. Now in this video, I'm primarily focusing on equations that just have a single variable like just x or just y. So let's look at an example and we'll talk about what we mean here. Let's say we have an equation 2m equals 6. Right, now 2m is not always equal to 6. It's only equal to 6 for certain values of m. And so it's up to us to find what values of m, if we double it, will give us 6. Well, for this example, I think it's pretty clear that m needs to be the number 3 in order to double it and get 6. So 3 is a solution to the original equation. M equals 4 or 5 or 6, those would not be solutions, because if you double 4, 5, 6, or 7, etc., you would not get 6. And so again, it's a value that when you plug it in for the variable term in the equation, is going to make the equation be true. Now the real challenge throughout our semester is going to be learning ways to find solutions. This can be a very challenging thing. If your equation is very, very small like this, you might can just look at it and just think about what value that you could double to get 6. And a lot of students do that early in the course, but that's a bad habit to get into, because very quickly what's going to happen is these equations are going to grow and get bigger and more difficult, where even the best of us will not be able to look at the equation and just say what all the solutions might be. Okay, so this is something we're going to learn throughout the course of the semester, but how we solve an equation really depends on what type of equation we're solving. We have different, you might call them methods of attack, depending on what type of equation we're dealing with. Here we have 5x plus 1 equals 36. That has some characteristics to it that we're not going to cover right now, but that would tell us we need to solve that equation a particular type of way. X squared plus 3x minus 28 equals 0. That's still an equation, but it's a different type of equation that has different characteristics to it, and we would solve it a different type of way. And x minus 1 over 5 equals 4 divided by x minus 9. That's another type of equation that would be solved another type of way. And so a big point of emphasis in our algebra class is learning these different kind of systematic approaches for how you handle different types of equations. So I've already worked all these examples out, and the focus of this video is definitely not to learn how to solve all these types of equations at all. That'll take a lot of videos and over the course of the semester, but let's just look at the solutions. The first one has a solution of 7. The second equation actually has 2 solutions. 4 or 7, negative 7 would be considered solutions to this equation. And for the last equation, 11 or negative 2/5, both of those are considered solutions. Now, even though you might not know how to solve all 3 of these at this particular moment, what you can do is this. You can verify that these really are solutions by taking these numbers and sticking them in for the variable in the equation. And if it makes the equation be true, then it really is a solution. But if you took a number, let's say like this 4 right here, and you plugged it in the second equation, and let's say it did not equal 0, then I told you something incorrect. But if you plug in 4 and it does equal 0, then it's a solution. So it's very easy to verify a solution, but it's very challenging sometimes to actually find a solution on your own. All right, the last 2 things I want to mention before I let you go is when you learn what a solution is, you naturally start to think that every equation must have a solution, when in fact that's not exactly true. Not every equation has a solution. Let me show you what I mean. As you well know, if you take a number, if you take a value and you square it, it's not going to be negative, because if you take a positive times itself, you get a positive, or if you take a negative times itself, you'd still get a positive. And so if you had an equation, and I'm making this up here on the fly here, let's say you had x squared equals -6. Well, that can't happen because regardless of what x is, if you square it, it's not going to be negative. So this equation here has no solution. And there's a name for this type of equation. If it doesn't have a solution, then this guy is called either a contradiction, because this is impossible. You can't have x squared equaling -6, for example. Or you can call this an inconsistent equation. All right. Either one of these are fine. You'll find either of these words in some textbooks. Some textbooks use the word contradiction. Some textbooks use the word inconsistent. Another way you can express this is when you write the solution set, you can either write the empty set as curly braces with nothing inside, and this is basically saying that your solution is, there are no solutions for this guy, there's nothing in the empty set. Or you can write a circle with a line through it indicating the empty set, meaning that there's no solutions to this equation. All right, and the last thing I wanted to mention was the fact that some equations have infinitely many solutions. Here's an example. Let's say you had something like 2 plus x equal to x plus 2. Well, 2 plus x is the same thing as x plus 2 regardless of your choice of x. 2 plus 10 equals 10 plus 2. 2 plus 7 equals 7 plus 2. So for every x you would have a solution. So the way you would write this is you would say the solution is either write out the words all real numbers, or there's also a shorthand notation for all real numbers. It's a capital R that has an extra bar on the front. This is kind of a bold-faced type of R. It's called blackboard bold that we use a lot to designate sets of numbers. So R stands for the real numbers. And this guy has a name as well. This is called an identity. So we have identities that have infinitely many solutions, and we have contradictions that have no solutions. These are somewhat rare. These are not the norm. Most equations have at least one solution, but you should at least be exposed to these types of equations just in case you happen to run into them.